session, we're going to be still using the grades 4-5 multiplication and division, which is going to be a much more complex problem as the grade levels get higher. This particular problem, when you first look at it, yes, it's pretty lengthy. So let's just dive into it. Sandy poured some fluid ounces of orange juice into a pitcher. She added so many times as much apple juice. She stirred the juices together and filled each bottle with some fluid ounces. How many bottles of juice would there be? So what do we know in this problem? We know that Sandy had some ounces of orange juice. So let's let this orange bar represent the orange juice. Now at this point, we don't know how many ounces. So what we know is that this orange bar is going to not only be orange juice, but it's going to be ounces inside here. So I'm just going to put a little OZ here. But I don't know how many ounces of orange juice yet. She added so many times as much apple juice. So what I know is that she's adding these orange juice and the apple juice. Okay, and it says that she stirred them together. Which action would that kind of represent? That we were taking some orange juice, we were taking some apple juice, and then we were stirring them together. That's right, that's going to be joining. So what I know is I'm at least going to have so many ounces of apple juice, but I don't know exactly how many. So I don't really know that yet. But what we know is that we are going to be joining these together, because that's the same thing as stirring them. It says stir the juices together. Then it says that you filled each bottle with some fluid ounces. And what do we need to know? How many bottles of juice would there be? So what I know, and remember in your teacher guide, it's telling you, to use your orange bars for your orange juice and your apple juice. And then it says to use the red bars to represent the bottles. So I know that there's gonna be some bottles. I don't know how many, because that's what we're actually trying to find out. But what I know is there's so much or so many fluid ounces. So again, this is gonna be ounces, but I don't know how many ounces we're gonna put in those bottles. What you can see from this is the first thing we had to do was we're going to join the apple juice and the orange juice to get a total number of ounces. Okay, and so that is our addition, and you've already said it was joining, and you're not necessarily going to join the same amount of ounces, but we can, and we'll find that out in a moment, whether they're the same or maybe they're not. But I'm thinking, because it says she added how many times as much apple juice, that means that the apple juice and the orange juice actually have the same amount. I just don't know how many of the apple juice we're going to use. Once we join those, then we're going to take this total and we're going to pull out so many ounces, so many ounces, so many ounces. And each of those ounces are going into bottles. So we're then separating. So this is why this is a two-step problem. We first of all have to solve this one. Then we will be able to separate. So I'm going to move our bars to the side for just a moment. And let's turn on the back now where we don't have the numberless word problem. And let's see if we now can fill in with these quantities. The problem says Sandy poured 40 fluid ounces of orange juice. So this is the OJ right here, 40 ounces. She added 3 times as much apple juice. 3 times as much apple juice as what? Orange juice. So if she did 3 times as much, then this one is still 40 ounces, but she's doing 3 times as much. So that means there were 3 40 ounces of apple juice and only 1 40 ounce of orange juice. She joined those together or stirred those together to get a total. So what is our total? You could do it that way, or your teacher guide said that your purple bar is exactly the same length. So what do we have here? How would we find the total amount or ounces of juice? So I'm going to write here, ounces of juice. Okay, we would have 4 equal groups of 40, which hopefully your kids will know that strategy of multiplying by tens. So 4 times 4 is 16, and 10 times as much is 160. So we have 160 ounces of juice. And that juice, the total ounces of juice, was made up from the orange juice and the apple juice. Then if you continue reading, she filled each bottle with 20 fluid ounces. So now we know that this is 20 fluid ounces. So the question is, you have a total. So if you start with a total, and we're going to separate this into some amounts. Those amounts may be equal amounts, they may not be equal amounts. But when you start with a total, that means we are separating. That also means, ask the kids at this point, then we know we're separating. Is this going to be, am I just subtracting 20 from that 160? Or am I going to see how many of these 20 ounces it would take until I have no more juice? So get them to talk and think through these actions. Even though it's a separating problem, it's not a subtraction, because I'm not just going to take 20 ounces out of that. That will still leave me with 140 ounces sitting over here. We're going to keep doing that. 20 ounces, 20 ounces, 20 ounces, 20 ounces. And then that's going to give me the total number of bottles that will be filled. So let's think about this. This is 160 divided by 20. The 160 is ounces. The 20 is ounces. And what are we going to end up with? Are we ending up with ounces? No, that's right. We're ending up with bottles. So what type of division problem is this? Is this partitive or is this measurement? That's right, it's measurement, because I know the number in each group. Okay? And then, of course, the 160 is your group. And it's both ounces. Labels are the same, but I'm looking for something different. Really, the only thing in mathematics that when you have labels the same, you're looking for something different is division. And then you're just going to divide. How many 20s are there in 160? So yes, you could repeat, subtract out 20, 20, 20, 20. But you also could think about this as groups of 10s. And of course, that would make those go away. So 16 divided by 2 is 8. And then 10 times as much is 80. So you would end up with, I'm sorry, not 80, 8. You would have 8 bottles, because 8 times 20 equals 160. And look right here, bottles are your groups, 20 ounces in each of those bottles, and I still end up with ounces. So that's an example of a two-step problem and how you would work it differently.